Here you can see the module and the expansion board, and this time we will control the ADC using the variable resistor and potentiometer connected here. As you can see, the USB port of the expansion board is positioned at the top as indicated here. Please connect it like this, with the top part fitting in. When connected this way, it will link to this module, and I will show you from the back that we will control it using the A55 pin. After plugging the module into the expansion board, please reconnect it to the PC. In my case, I connected and reopened the main file we worked on last time. Now, as you can see, I will delete this and try writing the code again. I'm not looking for a board at this very current moment in time. Look in, then from my sleep and ADC. Look in. As I mentioned earlier, there is an A0 pin on the board, and while we need to check the values, so we will make it print the values, we will print ADC and have it output every 0.1 seconds. However, the ADC value being checked in this kit is 16-bit. So since it's 16 bits, this means 2 to the power of 16, which gives a maximum value of 65536. But in reality, the maximum value is 65535. It reads the voltage value based on this. Since it operates at 3.3 V, if 3.3 V is fully filled, it would be 65536. And if it's 1.1 V, then half of that would be around 33,000. And if it's 0 V, it would read 0. That's how it works. Let's check it out. Right now, I have connected it to the kit as I explained last time through the serial monitor. So, you can see the output that is currently being displayed. In this state, I have this variable resistor currently turned all the way to the right, which means it is at its minimum resistance setting. If I turn it counterclockwise like this, you can see on the screen that the value is increasing. This increase is due to the reduction in resistance, allowing more current to flow through the circuit. Let me turn it all the way to the maximum counterclockwise position. Then it reaches almost 65,000, which corresponds to about 3.3 V. This voltage level is significant because it indicates the maximum potential difference that can be achieved with this setup. Now, if I turn it all the way clockwise again, the value gradually decreases. This decrease is a result of increasing resistance, which restricts the current flow, thereby reducing the voltage. In this way, it has almost reversed again. You can control the ADC like this. In this session, we connected CircuitPython with the BLE module and the kit expansion board to read the value of the variable resistor as ADC. I will return next time with another topic.